Hello, let's look at a higher order environment. So we are going to step through this rather convoluted example, which I made to sort of try to highlight a lot of common mistakes I see, tricky ideas, and also just the fundamentals. Okay, so let's start with our environment diagram. What is always the first step? Well, we're always going to start in the global frame. So on line number one, we get A is equal to 5. How does line number two differ? Well, in line number one, 5 is a primitive value. On line number two, we have it set equal to a function. A function is an object. Objects are too big to sort of fit in the box, so we're going to reference them using a pointer. Okay, so what is that on the right? That is the function signature. Okay, that is the intrinsic name of the function, the birth name of a function, and that name is never going to change, and it's going to be the name that we use to title our frames, which I'll show you later. Okay, so I have function. Lambdas are anonymous by definition. They don't really have a name, so we just annotate that with the lambda symbol itself. This function takes no parameters because there are no symbols to the left of the colon. And then since they have no names, what if we have a bunch of lambda functions? What do? We differentiate them by also specifying their line number. Its parent is equal to global. Why? Because this lambda was first defined in the global frame. All right. I've also sort of shaded away all of these inner lambdas, trying to emphasize the idea that these lambdas have not been seen by Python yet, right? When you get a scary higher order function, just work one layer at a time. These lambdas don't even exist yet. They can only exist once the outer lambda is called. And that is the same is true for this outer function. So I try to create the analog there, showing both a higher order lambda and a normal higher order function. Okay, let's step to define outer. The define statement, what does that do? It binds the name of the function outer to the actual function itself. So this is the function object. Its intrinsic name is going to be a copy and paste of the function signature. Parent is equal to global once again. Okay, so here is where all of the action is going to start. In a assignment statement, we first have to evaluate the value on the right. I see a call expression. So now we're going to follow those 3 steps that I hope that you've better memorized. So we start by step 1, evaluating the operator or the function in the current environment. Okay, so in the current environment, I'm going to search. We are in the global frame. I'm going to search for the word or the symbol outer. Do I find anything? Yes, I do. Perfect. Okay, so now I've identified the function that we're going to call. Why is this an important step? Well, let's say on line number 9, I said outer is equal to 3, right? So we can't just blindly call a function. We have to figure out what this symbol actually refers to. Maybe it refers to a different function, not called outer. Maybe it's a number, right? Python has to resolve the value of a symbol to figure out the function that actually is called. And then we're going to evaluate each operand left to right individually. 1 evaluates to 1, and A is going to evaluate to 5, stealing the value from the global frame. And on step 3 is when we apply the operator on the operands. And this is only when the frame finally opens, right? So a common mistake I see is students see a function call and they open up a frame right away. Well, that is not how Python does the steps internally. And why? Well, it makes intuitive sense, right? How can I call a function on something if I don't know what function I'm calling and what I'm calling the function on, right? So Python has to figure out those 2 components before it's ready to open up a frame and enter a new execution environment. Okay, so I open up a frame. What are you always going to title the frame? You're going to title it the intrinsic name of the function that was called the true identity, okay? And that will always be copy and pasted from the right side here, from all of these intrinsic names. So I'm going to copy and paste outer xy onto the name of the function. For brevity, we usually do not include the parameters. Okay, but you should never have to think about what to title a frame. It should be copy and pasting verbatim. Okay, same thing every time. Every time we open up a frame, we're going to create new bindings. What are the first bindings? We're going to bind the formal parameters, which are the parameters inside in the intrinsic signature, the function signature that define what the function expects to take. So x and y are going to enter my frame, and what do we bind it to? we're going to bind it to the actual operands or the actual values that were handed and passed into my function, being the 1 and the 5. So the 1 and the 5 are going to enter my frame and get bounded to X and Y. Okay, now that these steps are done, these are sort of the preliminary steps. Now we're ready to execute some code. And this is the part that is going to vary based on whatever function you have. So now we actually go into line number 4. I've unshaded it, but I've still shaded the inner function to show that this code won't be executed until inner actually gets called. Okay, so first line of code, a is equal to 10. We know how to do that. I'm going to define the inner function. And then, yeah, what interesting happened here, or what is interesting here is that the parent is now frame 1. Why? Because this function was defined. This function first exists in the context within frame 1. Therefore, that is the parent that it will take on, because the parent will always be where the function was defined, not where it was called. Okay, so we're going to bind inner to a function with the intrinsic name inner, takes uv, these are the formal parameters. And finally, we're going to return this inner function. Okay, so when I return an object, I'm going to return a reference to, or a pointer to that object. Okay, we've hit return. And from here, you always want to think about sort of who called the function, whose fault was it that we had to make frame 1, right? And that was because of line 10, because someone called outer on 1 and A. Okay, so that was the line that called. So that is the line that I'm going to hand this value back to. Okay, so observe that in the global frame, right, handing the value back here, and then I'm binding it to outer. So now I know that outer is soon about to point to inner. Okay, perfect. So now let's go to line number 11. On line 11, we are going to again call outer on 3 and A. So yeah, before I go any further, please think about what you think is going to happen. We're going to repeat the exact same steps. Step 1, evaluate the function in the current environment. Now we see why this step is important, right? Because if we skip this step, then we don't know what function to evaluate. We don't know when the symbol is bound to a new function. But if we do that evaluation step, we see that outer, the symbol outer actually resolves to the object inner. Okay, evaluate the operands, nothing interesting there. And this is a important point in that when you evaluate the operands, notice that I'm still evaluating them from global because that is where the function was called, right? I see oftentimes as students will open up the frame first, and then they'll look for A within frame 2, which I guess, like, I could see how that might make sense. But the idea is that A is evaluated before we even enter frame 2. Okay, so A has to be grabbed from the global, and that is why A is 5. Okay, so we come in, same steps. I'm going to bind the formal parameters as defined in the function signature to the actual parameters that the user passes in. So 3 and 5, those get bound to U and V. Now we execute some code. So I'm going to jump into my inner function. First line of code, y is equal to a function call on x. Okay, pause and think about what's going to happen. So ideally what we want to do is we want to call this lambda function that was defined on line 2, right? So the question is, will we be able to successfully find that x even though it's not defined in our current frame, right? So, okay. So we want to bind y to the result of calling the lambda in the global frame, but error, why? We get int not callable because if I try to call x from frame 2, we start our search here. I don't find it, so I'm going to recurse into my parent frame being frame 1. We have an x here that is bound to 1. The value of x in frame 1 so-called shadows or obscures the actual x that we're trying to call from the global frame, right? So, okay, how would you fix it? I sort of just spoiled it. But we can just fix it by making the identifiers, the symbols unique so that there is no name conflict. So let's just rename the function to fix. Okay, So now if I call fix on line 6, what's going to happen? So now I've sort of skipped the steps, but it's the same steps. Okay, so I call fix. We start in frame 2. I look for fix. No fix in frame 1. I look for fix in global. There it is. There's the function that we're going to call. I'm going to copy the signature with the lambda verbatim onto the new frame that I open, being frame 3. So frame 3 will be titled lambda with its line number with its parent, which you see is identical to the signature. Okay. This lambda really has no code to execute. The only code that might appear, or the only values that could appear in a lambda frame are formal parameters that it was defined to take, right? Because a lambda has no lines of code to execute. Well, here, these lambdas are defined to take no parameters, which looks strange, but I'm just sort of introducing it so you see different things. So there are no formal parameters defined, so it's going to return right away. What does it return? It returns a new lambda, okay? And I want you to think about who is going to be the parent of this new lambda. Is it going to be the same parent as the other lambda, or is it going to be something else? Its parent is frame 3, the execution environment in which we were in, right? The parent of a function is always where that function is first defined. And this function is first defined right now from frame 3. When we try to return it, Python actually creates that physical object and returns it to the user, right? So that is why I sort of did this. I noticed here before it was shaded. I was sort of trying to suggest the idea that Python doesn't even know these inner lambdas exist yet because they don't, right? It takes actually running the code. It takes calling the outer lambda for us to run the code here. And it is only that code that produces these inner lambdas. So that is why its parent is going to be frame 3. The first time the function is defined. Cool. Notice the inner lambdas are still shaded away. They do not exist yet. Okay. So if hit return, as always, you want to think about who am I returning this value back to? Okay. So it happened on line 6, right? So I'm going to return it to this call to fix. And I see we are in an assignment statement. So I'm going to hand the value back to y. So in frame 2, y is now going to get set to the lambda that we just returned. Okay. So now we are ready to enter the while loop. While 0 or a function call to y. So let's evaluate this Boolean statement. Or is going to keep looking for a truthy value, or is going to produce the last falsy value. So 0 is false, so we're going to keep looking. Now, this forces us to call y. Okay, same exact steps. I see parentheses. I know that I'm going to follow the same 3 steps and open up a new frame, regardless of where this function call is, regardless if it's a normal line of code or inside some sort of control statement. Okay. So I evaluate y. What does it y evaluate to? In my current frame, I see that y points to this lambda function with parents equal to frame 3. I see the parentheses, meaning we're going to call it with no operands because the function is defined to take no operands. And here we go. So I'm going to open up a frame 4. How do I know what to title this frame? It's copy and pasted right from here, the intrinsic name of the function. Okay. And then now I'm ready to return. Again, the lambda takes no formal parameters. And we see that this lambda has been unveiled. It has been birthed into the world. But in what environment? It has been birthed into the world from the frame 4 environment. Therefore, this lambda will be parent is equal to frame 4. Okay, we hit return. So I want to think, who am I handing this value back to? I'm handing this back to line 7. Okay, so I get 0 or a lambda function. As you remember from discussion, a function is a truthy value, which permits us to enter the while loop. So now we're on line number 8. Okay. Here I want you to notice that frame 4 was kind of useless, right? We called the function, but then we didn't do anything with the return value. So on line 8, when they ask us to call y again, it's going to produce an identical frame as frame 4. Frame 4 and frame 5 are going to be identical because they were both function calls to the same function with the same operands, right? So to restate, on line 7, we called y, but we didn't do anything with that return value. So no one was there ready to receive that return value, so it just gets lost. Python's going to delete it from our environment. On line 8, we're going to call that function again. So we're in effect doing the same thing that we just did on line 7, same function call, but it's actually different. Parents equal to frame 5. Why? Because now this lambda is birthed into the world from the context of frame 5, right? Okay, so this lambda and this lambda, they're actually the same function. That function being this final lambda that returns 0. They're the same function, but they were defined from different environments, and therefore they have different parents. Okay. Now, the return value does actually get assigned to the value y. So from frame 2, y is no longer going to point at this old lambda. It's going to point at this new lambda from frame 5. And we go back through the loop. While 0, or a function called to y, which is just going to return 0. We've sort of uncovered all of these nested lambdas. The final one just returns 0. Parent is equal to frame 4. Parent is equal to frame 4. Okay. Hi, sorry, I am back. I actually got confused by my own slides. So this frame open, I saw parents equal to frame 4. I was like, no, aren't we calling this lambda from frame 5? Yes, we are calling this lambda from frame 5. But this is also true if you paste this into Python tutor. It will give you this error. It will says it's ambiguous whether it's parent is frame 4 or frame 5. It's one of the unsupported features in Python tutor. It just can't really figure out which lambda is actually being called. So it's not sure if it's frame 4 or frame 5. So it will just annotate it. It says parent is equal to like frame 4 or frame 5. We know it's parent is equal to frame 5, right? This is the innermost lambda that we're calling. It returns 0 on line 7, and then it's going to or it returns 0, and then so while 0 or 0, nothing happens. So the function ends because there is no return statement, meaning I'm going to implicitly return none. And then finally, who are we handing this value back to? This was the function call, this return none. So I'm going to set res is equal to none, as you will see in the global frame. And that is all. Thank you.